Hey everybody, this is going to be my video on 1-4 Math Excel. So to start with, it says find the inverse of the relation shown below. You have a table, then draw your arrow. This is -3, -2, then the inverse would be -2, -3, just like that. Okay, our next one, we have to write the equation of the inverse, f -1, then graph. So our original equation is 3x minus 3, so we change that to y, and then we switch x and y, so we've got x equal 3y minus 3. The next step would be add 3, so that's why there's an x plus 3, and then we divide 3 to both sides. And so then this cancels, and so you get x plus 3 over 3, which is the same as 1/3 x plus 1. The next thing it said to do was to graph it, and so I used numbers that I thought were appropriate to the problem. If I do -3 plus 3, I get 0 on top, and it doesn't matter what's on bottom. If it's 0 over another number other than 0, then it's 0. And then I also chose 0 because 0 plus 3 is 3, divided by 3 is 1. And then just to be kind of like symmetric, so to speak, to the x's, 3 plus 3 is 6, 6 over 3 is 2. And so those are the points I used. Our next one is number 8, and so it says x squared minus 6. So our first step would be switch x and y, or switch x and f of x, so to speak. So I have x equal y squared minus 6. So then I bring the 6 over, got x plus 6 equal y squared, and I just reversed it without changing any signs, because you can do that. I just prefer having the y on the left. And then when you're taking your square root, you do plus and minus the square root. And so that's my inverse function, and it looks like that. So basically it goes left 6, and then there's your parabola. And the parabola in this case is the same thing as having a positive square root and a negative square root. Our next problem is about the Fahrenheit conversion with Celsius, and so I started with making my original y equal 9/5 x plus 32, and then I switch x and y, so x equal 9/5 y plus 32. Then we subtract 32, then we multiply by 5/9 to both sides, and so I have 5/9 parentheses x minus 32. Now right there we don't want to distribute, we just want to keep it simple, because usually they want to plug a number in there, and it'd be a lot simpler if you just keep it that way. So then we're going to just change x to f and change this one to c. So we have 5/9 parentheses f minus 32. Remember, your Fahrenheit temperatures are always bigger than your Celsius temperatures. And then because it's linear, it is a function, because it would pass the vertical line test. And then we're given 17 degrees Fahrenheit, and so you plug that in, and you get -25/3, which is this decimal, so that's -8.3. Now, remember on your calculator that if you do 5/9 parentheses 17 minus 32, it's going to show it as a fraction, but you want a decimal. So you can do this, have it, and then you can press Control Enter to make it a decimal, and then you round. If you forgot that, you can go to here and then say, what was it again? Go to Menu, go to Number, and convert to decimal. And so it gives you the same thing. So there's your -8.3 degrees. Our next problem is number 17. We have f of x is 16 over x, and we want to state the equation of the inverse the domain and range using set notation. So our first step is if we have y equals 16 over x, then we change it to x equals 16 over y. Then we're going to multiply both sides by y and divide by x. So if it's a rational function like this without any pluses or minuses, now that's the key, without any pluses or minuses, then your function and the inverse are identical. And when you graph this, it would have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So to do that, we press this twice. Let me just start clearing my scratch pad. Okay, I want to go to my graph. And I put 16 divided by x. So it looks like that. Now just regular 1 over x would look like this, which is closer to the axis. 16 just brought it out. But it still has a vertical asymptote at x equals 0 and a horizontal at y equals 0. Our next problem is number 18. On this one we have negative x squared plus 1. So again, switch x and y when we're doing inverses. So you have x equal negative y squared plus 1. So then what I did was I added y squared to both sides and I subtracted x. So I have y squared equal 1 minus x. So then I just want to take the square root of both, and whenever you're taking a square root, there is a positive and negative. So we have plus and minus the square root of 1 minus x. So if you graph this on the calculator, it kind of looks like that. For the inverse, for the original, it would have been an upside down parabola shifted up 1. So notice how if this were down, then the inverse is going to be left. And if this were up, this is going to be right. So that's the way it's related. So your domain and range of the function, your domain of the function is all real numbers. Your range is y less than or equal to 1. And again, the other way to put that would be parentheses, negative infinity, 1 bracket. Okay? So any low point up to 1, including 1. So those are equivalent. Then for the inverse, it looks like this, so that's x less than or equal to 1. So how these are related is that the other way to write this would be negative infinity, comma 1 bracket. Notice these are identical. Okay? Now, I know this has y and this has x, but if you have it in interval notation, this matches this. And that's how it's supposed to be. And then this one matches this one. So your domain of the function matches the range of the inverse. Your range of the inverse matches the domain of the... Your range of your function matches the domain of the inverse. Just kind of like makes an x. And because it fails the vertical line test, it's not a function. Okay, so for our next one, we have a function 2x minus 2, and we switch x and y, add 2 to both sides, and then divide by 2, and we get it. So f negative 1 equal x plus 2 over 2. The way it works, I don't want you to just guess, but in this case, if you've got times 2, then the inverse has divide by 2, and if this has minus 2, that's a plus 2. So think about how that's related, but be very careful if all you're doing is just guessing. It's best to do the work and then say, oh, that makes sense. So now we want to do the value of f negative 1 and negative 2. So what we do is we just plug -2 for x. You go -2 plus 2 is 0 over 2 is 0. And that's for the inverse function. For the regular function, we have f of -2. And so 2 times 0 is 0 minus 2 is -2. So again, just to recap, we always have to do this part first. And so that's the f -1 of -2. We got 0. And then we got to plug that 0 in here. So then we go 2 times 0 minus 2 is -2. For our next problem, we have f of x equal x plus 1 squared. So our first step, again, when we're doing inverses, is switch your y and x, or switch your f of x and x. So we have x equal y plus 1 squared. Then before we can break up anything, we've got to take the square root of both sides. Because think of it as if you have parentheses, then it's protected. So you cannot do subtract 1 until you square root. So we have plus and minus the square root of x equal y plus 1. And now you're free to subtract 1. I like to put it in the front because this is -1 plus or minus square root of x. And you can do that, or you can say plus and minus square root of x minus 1. Either of those work. But because it goes up and down like that, it's not a function. All right. Now for our next one, we have y equal 3x minus 8, so that's x equal 3y minus 8. You just switch x and y. Same thing throughout this. So now you just add 8 to both sides and then divide by 3, and there you go. And you might want to leave it in this form, but remember, just because it's a fraction doesn't mean it's a rational function. You could have thought of it as 1/3 x plus 8/3. So it's still linear in this form. And if it's linear, it is passing both the vertical and horizontal line test. For our next one, we have graph the relation and its inverse. So we start with y equal 3x plus 5. So I went up 5. And then what I did apparently was I plugged a 1 in. So 3 times 1 is 3 plus 5 is 8. And so I plotted those points. The other way to do it is if you do your 0, 5, then since your slope is 3, you go up 3, right 1. And then again from here at the 5, you can go down 3, left 1. So anyway, graph your function. Then for your inverse, the easiest way is just take the 0, 5 and flip it to 5, 0, and take your 1, 8 and flip it to 8, 1. That's the easiest way, and then graph it. It didn't ask you for the other function, but you could have given it this way and then plugged in numbers. You'd have x equal 3, y plus 5, and then subtract 5, and then divide by 3, and then plugged in numbers. 2 minus 5 is -3, divide by 3 is -1. 5 minus 5 is 0, 0 divided by 3 is 0. 8 minus 5 is 3, 3 over 3 is 1. So either way works for that. Okay, this is the next one, and the problem says the relation is blue and the inverse is red. And so this one you can do online, but you cannot do on a paper test. So what we have is y equal x plus 4. Remember, the plus means it's going to be left, And so this is left 4 and quadratic. So how you can check that is you go x plus 4, whoops, add graph, go x plus 4 squared. That does indeed go left 4, so that's your vertex and your minimum of the quadratic function, which again is a u, and it's a parabola. And so that's your original, and since it's up, then your inverse is going to open right. So if I had y equal x plus 4 squared, then you have x equal y plus 4 squared, because you switch x and y. Then you need to take the square root of both sides, and it is a plus and minus, and then you move your negative 4 plus or minus the square root of x. So you just subtracted 4 from both sides. You can put it in the front or the back, it does not matter. Now, for the negative 4 minus square root of x, I have a couple of points. 0, negative 4, and 4, negative 6. So 4, negative 6. And when I had negative 4 plus the square root of x, you still put 0 there and you get negative 4. And then the square root of 4 is 2, so negative 4 plus 2 is negative 2. So here you get 4 comma negative 2. Of course, that fails the vertical line test. And so the inverse is not a function. Our next one is extra practice E. So if you have x to the 14th, then x equal y to the 14th. So then since something's to the 14th power, then you have to do the 14th root. It's kind of like if this were x squared, then you do the square root. If it were x cubed, you do the cube root. But since it's plus and minus, it would not be a function. Okay, so then for extra practice F, you've got the cube root of x minus 1. So again, switch x and y, do cube both sides, and then move your 1 over. So you have x cubed plus 1 equal y. So notice the original was cube root, so this one has cubed. And again, this one had minus 1, so this one has plus 1. But this was a move it right, and this was a move it up. Then our last one, this was your table, and to get the inverse, we just switch our x and y. So very simple. This is another one where the problem says the relation is blue and the inverse red, and so you just plot your points. So the relation is above and the inverse is below.